Hello and welcome to Algebra 1, Chapter 3.4, and today we're going to discuss arithmetic sequences. So arithmetic sequence, first of all, just a sequence is a set of numbers that are called terms in a specific order. To be an arithmetic sequence, the difference between the terms needs to be constant. So for example, down here at the bottom, to go from 6.3 to 14.5 is plus 8.2, and then again another plus 8.2, plus 8.2. And so if every time I'm adding 8.2, that's an arithmetic sequence. Okay. In other words, it's a numerical pattern that increases or decreases at a common rate. So you could also be subtracting a certain number, but as long as it's the same number every time. And that number, that's their difference, is called their common difference. So it's the difference between terms. So the first thing we want to do is just decide, are these arithmetic sequences? So you're looking for a common difference, like how do I get from negative 15 to negative 13? I'm going to add 2. And from negative 13 to negative 11, I'm going to add 2. And from negative 11 to negative 9, I'm going to add 2. Yes. And it says explain because add 2 every time. Okay, what about the next one? Don't let the fractions mess you up. Subtract 2/8, which would be a fourth, right? But 7/8 minus 2/8 would be 5/8. What about the next one? We subtracted 4/8. And the next one, we subtracted 6/8. Now that's a pattern, but that is not a common difference. So no, because no common difference. It has to be the same that we're adding or subtracting every time. Okay, so the next one, plus 4, plus 4, plus 4, right? So yes, because we added 4 every time. And what about the last one? Plus 3, plus 5, plus 14. No, because there's no common difference. And if we look at this last one, it's a pattern, it's just not the pattern we want. This is 1 squared, 2 squared, 3 squared, 5 squared. We must have forgotten 4 squared in there. All right. The next thing we're going to do is we're going to actually write the next terms in the sequence. So if you know the common difference, all you have to do is continue that pattern and you know the next terms in the sequence. So if we have negative 8, negative 11, negative 14, negative 17, okay, and these happen to be daily low temperatures, find the next 3 terms. So you need to first find your common difference. That looks like minus 3. Make sure it's the same the whole time. Minus 3, minus 3. So if I minus 3 more, what would I be at? Negative 20, and then we want next 3, so we need the next one. Negative 23, and the next one, negative 26. So our next task is going to be to write an equation for any term. And to do that, we're going to look real quick to see if we can see a pattern. So the first term, its symbol is a sub 1. Okay, that's the first term. And my first term, if I look here, my first term is 8. And so in terms of a sub 1 and d is my common difference, it's going to be a sub 1 plus 0d, because it's just a sub 1. Right? This is just a sub 1 over here. My second term is going to be a sub 2. To get there, I'm going to take a sub 1 plus 1 of the common differences, because this, in this case, it would be plus 3. Okay, and in our case here, it would be 11. Or, probably should write it, let's write it 8 plus 3, which is 11. The third term is a sub 3, which is going to be a sub 1 plus 2 of the common differences, because it's 2 common differences away. So this is going to be 8 plus 2 times 3, which gave us 14. I'm going to rewrite the top one here real quick in terms of these other ones. 8 plus 0 times 3 was 8. This was 8 times, make them all look the same here, 1 times 3. All right, the fourth term is a sub 4. Okay, I'm going to add the 3 another time. So this is going to be a sub 1 plus 3 of the d's, which is 8 plus 3 times 3, 8 plus 9 is 17. And we could continue this pattern, and so hopefully you see this pattern here. First of all, so for any term, that's my nth term, n is for any term, it's going to be a sub n. So it is a sub 1 plus. The key thing here is, what about this number? This number was always 1 less than this number, right? So term 1, we did 0. Term 2, we did 1. Term 3, we did 2. Term 4, we did 3. So 1 less than n times d. That is going to be our equation for the nth term. Okay, so the nth term is a sub n, and it's going to equal the first term plus n minus 1 times the common difference. N does have to be a positive integer. You can't have like the 3.5 term. You know, it's either the third term or the fourth term. And we're not going to have negative terms. We start with term 1. So if this is our arithmetic sequence and it represents total number of dollars Erin has in her weekly allowance, or in her account after her weekly allowance, we want to write an equation for the nth term. Okay? So my equation is a sub n equals a sub 1 plus n minus 1 times d. And so we need to fill in a sub 1, well, not n, because n is going to be n, a sub 1 and d, and then we need to simplify. So my nth term, or my equation for my nth term, a sub 1 is 1 plus n minus 1 times d. So what is d here? What am I adding every time? I'm adding 9. Okay, I don't want you to leave it like this though. I want you to simplify. So 1 plus, you're going to distribute 9n minus 9, which is going to give you negative 8 plus 9n. Right, if you combine like terms, 1 minus 9 would be negative 8. There is your equation for your nth term. So what this means is I can put in any term I want for n, and this is going to give me that number of that term. So for instance, if I put in 3 for n, put in 3 here for n, 9 times 3 is 27, minus 8 would be 19, and that was my third term. The second thing this wants us to do is find the 12th term. So a sub 12, all I'm doing is putting 12 in for n, just like that. And we're going to work this out. Negative 8 plus 9 times 12 is 108. And negative 8 plus 108 would be 100. So the 12th term, a sub 12, is the 12th term. It would be 100. And the third thing we want to do is we want to graph the first 5 terms. Your graph is going to be in the first quadrant. Well, it doesn't have to be. It could be in the first or fourth quadrant. Your x is your term number, meaning first term, second term, third term, fourth term, fifth term. Your y is going to be the actual value of the term. So first of all, I need to find my fifth term. I don't know my fifth term. My fifth term is 37. So this needs to go up to 37, so I'm going to count by 5s. Go up a little further to 40. And you're just going to plot points. You're not going to connect these. Okay, these are just going to be 5 points. 1, 1 is a point. Sorry about that. 2, 10 is a point. 319 is a point, 428 is a point, and 537 is a point. And these should be linear, okay, because you're adding that same amount every time. And that's what you're going to do. So there's writing the nth term, finding the 12th term, and graphing the first 5 terms. That's what I have for you today. Let me know if you have any questions, and have a great day.